Aphios Corporation is developing technology and products to improve the oral bioavailability of proteins and peptides, such as insulin, to improve the quality of life of diabetics. Diabetes is a significant and growing problem in the world. Insulin is usually administered by subcutaneous injection since it is rapidly degraded in the GI tract and stomach. Aphios is utilizing nanotechnology and biodegradable polymers to make insulin orally bioavailable by protecting it in the digestive tract and stomach and delivering it to the small intestine and bloodstream.
Polymers are often used in manufacturing highly durable, long-lasting materials. But some polymers are intentionally made to break down at a controlled rate under specific conditions. Advances in polymer science are opening the way for new drug delivery systems. Trevor Castor at Aphios Corporation has developed an innovative way to encapsulate insulin in polymer nanoparticles.
Traditionally, insulin is introduced in the body as an injection. You have to find a secure place to do an injection, making sure that your insulin product is refrigerated. You have to worry about potential of creating an infection. And if you have to inject that every day, it becomes difficult to maintain that type of adherence. What our hopes and ambitions is really to improve the quality of life of diabetics, so that taking insulin will be like eating food, basically. This is part of the holy grail of biotechnology.
Normally, insulin, if swallowed, would be quickly broken down in the digestive system and never reach the bloodstream. Aphios researchers are enveloping insulin in a polymer that resists the digestive acids and enzymes long enough to make it into the bloodstream.
So what we have done here at Aphios is to encapsulate insulin in biodegradable polymer nanoparticles. We take a polymer and we mix it with a solution of insulin, and the insulin is encapsulated in the polymer. One of these biodegradable polymers that I speak of is polylactic acid, and it's a long chain polymer, so it's a repeating unit of lactic acid, and it can break down. It's biodegradable.
It is a considerable challenge to find a polymer that is resistant to digestion, can attach itself to insulin, and eventually degrades to release the insulin, all while being harmless to people.
We've done experiments to show that these nanoparticles do survive in the stomach because the biopolymer is resistant to the pH of the stomach. And from there, because they are small, they'll be transported into the bloodstream. In the bloodstream, the particles will degrade with time, and the polymer will be released, and insulin will be released from the polymer.
The solution of insulin polymer nanoparticles is freeze-dried to form a powder, from which a time-release insulin pill will be made.
It's almost like an onion, where you have layers of polymer covering the insulin. And as the biodegradable polymer degrades, it releases layers, and insulin is released as a result.
Biodegradable polymers could be the key to making ingestible pills that would improve the lives of people with diabetes and other lifelong conditions.
I would like to see drugs being encapsulated in polymers to control blood pressure, control cancer, control a number of diseases, where we can take them on a daily basis, very much like I now take aspirin.
While oral insulin represents one of the holy grails of biotechnology and drug development, our oral delivery technology can be utilized for the delivery of other proteins and peptides. Should you need further information, please do not hesitate to contact us.